Augusta National is in full bloom in early April and ready for the Masters Golf Tournament. My fondest Masters memories include Jack Nicklaus making his putt on 17 in 1986 and Freddie Couples not going into the water at 12 in 1992 when he won. Welcome back to another episode of Polymers Club's Ask Dr. Paul. Today we're going to highlight the glassy to rubbery transition of plastics and elastomers. So when your boss says glass transition temperature or TG, what do you need to know? We know that plastics are rigid at room temperature, like a spoon, and elastomers are flexible, like a rubber band. With the modulus temperature plot on your screen, you can see that plastics, which are shown in red, lose their modulus after these two blue lines. Those blue lines are room temperature, use temperature, 15 to 30 degrees C. So plastics lose modulus after that. That's why they're rigid at room temperature. That drop area is really TG. So for polystyrene, 100 degrees C is common for TG. It'll be rigid at room temperature. Elastomers, they lose modulus left of the blue lines. So that means their TGs are very low. Natural rubber has a TG of minus 60 C. So at room temperature, they're very flexible. There's a huge difference in modulus at room temperature between plastics and elastomers. About 2 to 3 orders magnitude difference in modulus. And that's why we don't eat ice cream with a rubber spoon. I have a rubber spoon here, I have ice cream, and we cannot eat it. You cannot scoop up the ice cream. There's just not enough modulus or stiffness in the rubber spoon to scoop up the ice cream. I'm sure if you thought about it, we could get a Viagra joke going here, but we won't do that. If you cool down an elastomer below its transition temperature, meaning if you head left, we'll see that change, right? At room temperature, it's flexible, but once you get beyond TG, all of a sudden the elastomer will feel rigid. It'll feel very plasticky. And we could do the same thing with plastic sample. If you took polystyrene, it would be very rigid. And as we're heading right, as we get beyond TG, all of a sudden it would have that flexible feel. Knowing that plastics and elastomers have different glass transition temperatures that make them rigid and flexible at room temperature, that's working knowledge. Remember to like, subscribe, turn on notifications, and even share if you appreciate the content. I'm Paul Nash for Polymers Club's Ask Dr. Paul. Thanks for watching.